My grade did go up.
Okay, so we're doing implicit differentiation. This is when we've found the derivative with respect to x, and the functions have only had x in them, right? But we're going to find the derivative with respect to x, and they're going to have other variables in them. So that's what we're going to be working on.
Are the notes going to be long today?
I don't think overly long. As long as you don't write like this, there's not a whole, don't be writing this stuff. Like, don't write this stuff. It's not going to help you. It's just background. Okay. No, well, you might want to know that, I guess. But, so when I'm talking about the difference here, we have been doing explicit differentiation right here. Yes?
Yes.
Right here. This would be, that was interesting. This, and it's going to jump on me again because I touched it without the pen. The xy equals 1 is implicit right here. Now, what is the difference between this implicit one and the explicit one?
Excuse you. Sorry. No, I'm just kidding.
Explicit is equal to y, yes?
Yes.
Yes? Implicit is not. Now, this would be really easy. I could go, then this shows you, I can go from implicit to explicit just by dividing by x, correct? But can I do that with every equation? No. So, and then the derivative we found really easily. So what we're going to be dealing with are problems like this that we can't just take care of. So, differentiating with respect to x. So the first one, I have d dx of x cubed.
Can we write first?
Mm-hmm. So I have d dx of x cubed. So what is the derivative of x cubed?
3x squared.
3x to the second.
Mm-hmm.
Okay, so it's 3x to the second. I did that. I just used my normal power rule, didn't I?
Mm-hmm.
Okay, but now I have the derivative of x of y cubed. Okay, what do I have down here? The derivative of what? X. Do I have an x?
No.
No. If it was derivative of y, then it'd be great. But these two do not match, do they?
No.
So
Okay.
it's just 0.
So, no. So what we do is we take the derivative of the, what we have, so 3x squared, and then we put dy dx. Because that was the derivative of y with respect to x, wasn't it?
So it's 3y
Okay.
squared.
So it's 3y squared dy dx.
You said x.
Oh, I'm sorry. 3y squared dy dx.
Is that it?
Mm-hmm. So on 6, I have dy dx of x plus 3y. So on the bottom is with respect to what? X. So we're going to, normally we take the derivative of x and we add it to the derivative of 3y, yes? So it's the same thing we're going to do. So what is the derivative of x? 1?
Yes.
Yes? Plus, what is the derivative of 3y?
3.
3, but we're with respect to x, so we put dy dx.
Makes no sense. Oh, so we can just do 4?
No, because this is 3 dy dx. That's
Okay. So if there's ever a y, you plug in dy dx for it.
After.
Getting the...
yes, because it says you differentiated y with respect to x. Now, if this one was like a 4 dy dx, if I had 4 dy dx and 3 dy dx, I would have how many dy dx's? 7. 7. So if they're like terms, I can combine them, but these are not like terms,
Are
correct?
you recording?
Mm-hmm.
Okay. I just went
Okay, so now we have the next one. So what rule am I going to do to differentiate x, y squared? I'm going to have to use what rule?
Chain rule.
Nope.
Derivative.
No.
What's going on with the x
Quotient.
and the y?
They're being multiplied together.
So the product rule.
Product.
Project. Yep, product. I knew
Okay,
that.
so product means derivative of first times the second plus the derivative of second times the first, yes?
Yes.
Okay, so derivative of x, 1. So I have 1 times y squared plus x times
2y.
2y dy dx. Yes?
Yes.
So I can write that as y squared plus 2xy dy dx.
Uh-huh. So how would you write like so it's equal to dy over dx?
Oh, yes. And I don't think this should be equal. Like, there should not be an equal sign right there. Should there?
Or on the top one?
No.
So it's dy dx equals y.
Yes.
Should it be like that?
Because we're doing dy dx of, and then dy dx
You don't have to
equals.
put like a number next to it, like a line, like y first derivative, like you have to do for that normally.
No, because the dy dx means first derivative.
Okay.
If I had the second derivative, I'd put a 2 on there. Okay, guidelines for implicit differentiation. Okay, differentiate both sides of the equation with respect to x.
You want us to write this?
Yes, you do.
All of it?
Mm-hmm. Well, if you want to paraphrase, I guess that's up to you. 2, collect all terms involving dy dx on the left side of the equation and move all other terms to the right side. Guys, you really don't have to move it to the left and to the right. You have to move them to separate sides. Does that make sense?
Yes.
Yeah.
So that one, I would probably say solve for dy dx, but
For which one?
the second one, I don't know if I would put it that wordy.
So just write solve for dy dx.
Or segregate. I don't know how you want to say that. I would have
Separate?
you want dy dx on one side of the equation and everything else on the other.
You said that was for 2.
Yeah. I mean, to me that seems like move
dy
dy dx to one side of the equation and everything to the other. That
makes sense.
Oh, look what I forgot on equation.
E.
No.
U,
A
A.
U. Go away. And an A. I'm finding some typos, aren't I? And then factor the dy dx out of the left side of the equation and solve for dy dx. All these are solving for dy dx. Like this 2 and 3 are what you have to do in order to solve. Does that make sense what I'm saying?
Did we do all these steps already up above?
No, we didn't solve any. We just differentiated. If I was doing this on my paper, I would put 1 and I would put 4. Well, I'm just saying, these two are what you have to do in order to solve.
Yeah, I probably would have wrote down all 4 anyways.
Yeah, that's why I didn't tell you to only write down one.
I did write down all 4.
Okay, are we ready yet? Yeah? Gentry? You
Yeah.
good?
Sorry.
Okay. Okay, so it says find dy dx of this. So, okay,
Yeah, I like when we have a second to write it down so I can really focus.
I'll go back just a second.
Is this the one we're supposed to be writing?
Yeah.
Mm-hmm.
You just cast them. Are you drawing while you wait again?
Well, no, I was trying to see if I could do with that pen then rather than this pen, because that's how I used to do them all the time.
You ever just have a piece of hair that's like tied to another piece of hair so it seems really long?
Or you pull one and then you're pulling along.
But then it comes out and you realize your hair's...
No.
Okay, you guys ready? Okay, let's see if I can do this. Okay, so my first rule was to take the derivative of both sides, yes?
Yes.
So, I have to do dy dx here. Oh, it might work if it wasn't so laggy.
Which would be 0, right?
And dy dx of the other side. So yours is written on another line, so... Yes, which would be 0, correct? Because it's a constant?
Uh-huh.
Okay. Can I put that over here on the left? I don't want it on the right.
Yeah.
Okay. So I have the derivative. Yeah, I'm not going to like this. Okay, so I have 0 equals, and then I just go through and find the derivative of all these pieces. So the derivative of y cubed is
3y.
3y squared dy dx. Why do I have to add the dy dx?
Because it's in relation to
Right.
the
Okay, and then plus 2y
dy dx
dy dx minus 5
dy dx
dy dx
minus 2x.
minus 2x, and we equal 0. Yes?
Why does there no dy dx on?
Because it's with respect to x, and
So if the-
we're in x.
If it was dx over dy, will it ever be like that?
It could be, but
So
not
if
probably
it
in
was
here.
like that, it would just be 3y squared plus 2y minus 5 minus 2x dx dy.
Yes,
Also,
Exactly.
Why is it 0 equals?
because that's a constant.
That's the other side.
That's the other side.
Even?
Hmm?
What's constant?
The derivative of any constant is 0.
There's no x.
Like without a...
Because
X.
it's really negative 4x to the 0. Well, 0 times 4 is 0. And then be x to the negative 1.
I
So
didn't know
the
we were
thing
finding
is...
the derivative of
Yep,
that.
you're differentiating both sides.
Okay.
Okay, so now it said to move all the dy dx's on one side. So I'm not going to move them. I'm going to move the 2x. How about you? So it's going to be 2x equals, and then it said to factor out the dy dx's, correct?
Yes.
So I put the dy dx's at the back. So when I factor the dy dx's out of all these, I get 3y squared plus 2y minus 5 dy dx.
Mm-hmm. That makes it look a lot nicer.
Yes. And now this is the quantity times dy dx. So how do I solve for just dy dx? Divide. So I have dy dx equals 2x over 3y squared plus 2y minus 5.
So what'd you do to get that?
Because it's this quantity times dy dx, I just divided over.
Oh, okay.
Nice and pretty, huh?
That's how you leave it?
Yep.
We better not learn how to solve for that.
We will. We'll have to
What?
find the
What?
slope and stuff. Ready?
Yeah.
When's that?
Okay, so it says find the slope.
The next slide.
Okay, so we need to find the slope. So in order to find the slope of the tangent line, we have to find the slope function, which is the derivative, yes?
Yes.
So I need to take of x squared plus 4y squared equals 4. I need to take what? dy dx. Both sides, yes? So dy dx of 4 is what?
0.
0.
Just 0. Just 0.
Just 0. And what does the other side give me?
2x plus 4, oh no, 8y dy dx.
Okay? But now I need to move the dy dx and solve, right? So you guys want to subtract.
Divide.
Well, you can't divide yet. You got to move the x or the y.
The x.
Okay, so it's going to be negative 2x equals 8y dy dx.
I did that.
Oh, at dy dx. And then what?
Divided by 8y.
Okay, so dy dx equals,
1x over 8y. Can you do
well,
that?
it's
Or
2.
4y.
It's 2x over 8y, but we should simplify that to negative x over
4y.
4y. So what we just found was the slope function, yes?
Oh, I wish we would have slowed down.
Well, tell me. The slope function of what?
The tangent.
The tangent line.
So do we have to plug in then?
Mm-hmm. So M, we have an x and a y, yes?
Yes.
Do we have an x and a y?
Yes.
Yes. So what's x?
A square root of 2.
So I have negative square root of 2 over 4 times, and what's y?
Negative 1 over square root of 2.
So
Negative 1 over square root of 2.
4 over square root of 2.
Yep, so negative 4 over square root of 2. So when I'm dividing fractions, I have to multiply by the,
Reciprocal.
so I have negative square root of 2 times negative square root of 2 over 4, right? Because the reciprocal of this.
Mm-hmm.
And negative times a negative is a,
Positive.
and the square root of 2 times the square root of 2 is
2.
2. So 2 over 4, which is
Half.
1/2. So that is the slope of the what?
Tangent line.
Yes, you guys neglected to remember that on your test. Correct?
We have to label it?
No. I am, because you guys forgot it. So if you're forgetting it, so should you be labeling it?
Maybe.
Probably.
Do we have any more notes?
Yep, just examples. I just want to make sure we're working enough together. Good?
Are you going to record tonight or?
No, tomorrow's just extra practice on this stuff.
Okay.
And you said you won't be here tomorrow?
Thursday.
Thursday, okay.
Can we write it first?
Yep.
And neither will Riley.
Okay.
We're going to volleyball.
That's fun.
Determine the slope of 3x squared plus y squared equals 100xy at 3, 1. So, is this problem exactly like the other?
No.
Yes. No. Yes, it is. It's exact. I mean, like what you're doing.
Yes.
Finding the slope at a point and
So we
finding the
should
slope
do it
of a
by
tangent.
ourselves,
Okay.
Yes.
but we have to do the chain rule.
Yes, you have to do the chain rule.
Oh god.
And you have more than just a constant on the other side.
If you,
You guys want to start it, and then I'll help you simplify it? How about that?
Really?
I can, do you guys think you can do that on your own?
I think you could do...
I think so.
That was
Okay.
interesting. I think you could do dy dx of both sides. Try it.
Okay.
Okay?
What?
Try
You
the...
have to do the chain rule first.
No, well, you have to do the dy dx of both sides. So, try it. I'll start working on it, too. I'm going to put the right-hand side on the left because it's shorter. The 100xy. Just...
I don't understand. Okay.
$100Y.
She means X, Y, I think.
No.
No?
No.
Okay.
Because you have product. You have x times y. So I put 100x times y. So the derivative of 100x is 100. Yes?
Oh, yeah.
Times y plus 100x dy dx. I did the product rule.
I did it wrong.
You see it wrong.
Right.
So, the 6, where did it come
The chain rule.
The chain rule.
from?
How do you multiply them by each other?
Okay, well, let's look what we got to do. Because we got to be able to get to this dy dx, don't we?
Mm-hmm.
And in order to do that, it looks like we're going to have to, aren't we?
Yeah.
Because we can't subtract it over, we're going to have to. So this would be, what, 6x squared plus 6y squared?
Mm-hmm.
And then I've got to multiply it times this. I've got to FOIL it out. Pick up my mess. Yeah, this is a long problem, see?
And you accept it.
Yes?
I want to know if I multiplied it out correctly.
Okay, I'm just looking what I did. I kept my 6 out. Why did
I didn't.
I know. Okay. I'm just saying the first time I worked
Oh,
it.
okay. Does it matter if I put the 12y x squared? Does it have to be 12x squared y?
Well, we normally put the x's first because it's alphabetical. Oops. Did you guys get the same thing I did?
No.
No,
It should
because I
be
have
16.
2xy squared, not 16.
Oh, it shouldn't be 60, it should be 12. Shouldn't it?
That's what I got. Yeah.
I don't know where I got 16. Okay, so it says move all the dx's, dy's to one side and everything else to the other, yes? Okay, so we'll move dx, dy's over here to the left. Now when I do that, I kind of factor at the same time because these are lots of steps. And then I'm going to move this over here, right? The 100 over here.
Mm-hmm.
So I'm going to start off with 100x and then minus 12x squared y. It won't be in order, will it? And
Where are you
then
getting this?
minus, I'm moving these over. My dy,
Would it be
dx's.
100y, not x?
No, I want my dy, dx's on this side. I'm going to take this.
Oh, okay.
I'm factoring it out at the same time.
Okay.
And then minus 12y cubed.
Yeah. Mm-hmm.
Okay.
Negative 100y.
I'll put that at the end.
Oh.
So I have 12, but you can put it wherever. 12x cubed plus 12xy squared
Yeah.
plus, oh, not plus, minus
Yeah.
100y?
Wait, so do you have a negative on the outside of those brackets?
No.
That's
I think it just was an extra mark. I was pointing at it.
Okay.
Okay, now I have to divide by this. Right here? Yes? So dy dx equals 12x cubed plus 12. Actually, I'm going to factor that 12 out.
Does 12 go into 100?
Well, I'm going to factor just these two. I'm going to show you why in a second, because I think I see something going on. What do these two have in common?
12x.
12x. So then I would have
X squared.
x squared plus y squared minus 100y. And then when I bring the other over, I'm going to do the same. I'm going to take these, the 12s. So that would be negative 12y, wouldn't it? And then you would have x squared plus y squared plus 100y. Oh, 100x, sorry.
So it's basically the opposite.
Yep.
That's the answer.
Well, we have to find the what?
Slope.
Slope. We found the slope function, right? So how are we going to find the slope?
Plug it in.
Plug in what?
The points.
The point. The x and the... This one we have to plug the x's and the y's because the equation has both x's and y's, doesn't it?
Yeah.
So m at 3, 1. Would be, what, 36 plus 9, or times 9 plus 1 minus 100. Tell me if I'm wrong. I just don't have room to, like, plug it in and take a million steps. And minus 12 times 9 plus 1. Plus 300. That's what you guys got?
What's 300 minus 120? 80?
Oh, we so should have taken a 4 out of all of this.
Where's your answer?
I'm not done yet. But shouldn't we have taken a 4 out of all that?
Yeah.
Yeah. Because 4 goes into 12 and 4 goes into 100. Okay, so now I got 9 plus 1 is 10, right?
Mm-hmm.
So I get 360 minus 100 over negative 120 plus 300.
Does 4 go into 18?
No. 2 does, but not 4. So I get 260 over
13 over 9.
18. And you get 13 over 9. And we would have got 13 over 9 if we would have taken the 4 out. It would have been a little bit easier.
Taking the 4 out of what?
Back here, could we have taken a 4 out of the 12s and the hundreds?
Can we have taken the 12s out?
No, because 12 doesn't go into 100 evenly. I mean, you could if you wanted a fraction.
We have a fraction.
No, a fraction in a fraction. Okay.
Is that the last one?
I think I have one more. Just, it says find. What does this one want? Second derivative. How do you know?
2.
Because the 2's.
This isn't going to be as long as it.
No, because it's not. I mean, the right hand side 0, isn't it?
Why is it dx squared or dx d2y over dx2?
Because it's the second derivative.
We can do this one on our own.
Yep. I'll give you start time.
On our own. Nice.
Oh, dude. Where'd it go?
I found it. Now it's gone.
Both of them?
Now it's back.
Did you go to the second derivative? Or do you found mine?
No, I
Oh,
found
okay.
your thing on the screen.
Now, I'd encourage you to solve for dy dx every time before you start the new one. It will work much easier.
I think I did this wrong.
That's what I got.
I'm confused.
Where?
I don't know how you got -1 and -4.
Because I moved it from the denominator here into the numerator because I didn't want to do the quotient rule.
Yeah, but I mean the step after that.
So the derivative of negative x is -1. So -1 times the second. And then it should be plus, but the x is negative, so it's going to be minus x times the derivative of the second.
Okay.
Oh, I forgot my... I think I'm right. Is that what you guys got?
For what?
Your answer? Did you get the same answer as I did?
Yeah.
Can't solve it. It says it can't solve it. Let's see if they got the same answer, because I'm sure I got the book thing out of here. I think I messed up the second derivative.
Oops.
What'd you guys get? Did you get your first derivative right?
Yeah.
Yes?
Mm-hmm.
Okay, what'd you get for your second?
What you had, because I put down.
Yeah.
That's not the way to work together. You're supposed to say, Mrs. Mick, you made a mistake.
This is the first time I haven't used pen on a note.
Can I look up my
Okay.
proper school book for this class?
No. Okay, so let's do this. Let's do the quotient rule. Because I think I messed up because I didn't do the quotient rule. Do you get what I'm saying?
Mm-hmm.
Okay, so let's do this, the derivative of that. So we basically have dy dx of negative x y okay. So then quotient rule says derivative of negative x is what? -1 times the denominator, right? And then minus the first, which would be negative x. So minus the negative x would be what? Plus?
Yeah.
Plus x. And the derivative of y would just be dy dx. All over what? Y squared? Okay, now this is...
Why are you putting the dy dx on the y?
Because you had to find the
Or
derivative,
x?
because it's the derivative of the denominator, and the derivative of y is dy dx. It's 1 times dy dx, yes?
Mm-hmm.
Okay, this is where I messed up. When I said, oh, I didn't put the dy dx in there. Well, that makes a big difference. Do we know what dy dx is?
No.
Yes, we do.
Oh. Oh, yeah.
Isn't it right here? So can we substitute this in for that dy dx?
You would multiply by the reciprocal.
So, no, we'll just plug it in. So I get negative y plus x times negative x over y over y squared. So there's a couple ways we could do this, but we need that numerator into one fraction, don't we?
Yeah.
Yep. So this right here would be negative x squared over y, wouldn't it?
Mm-hmm.
And this y is over 1, so we need a denominator of what? Y? So how do you get 1 to be y? You multiply it by what? Y. So I get negative y squared plus, not plus, how about minus? Because it was negative x squared, right? Minus x squared all over y, all over what? Y squared. So this y squared is going to be 1 over y squared. So you get what in the denominator now? Y cubed. So d2y d. So the second derivative is equal to negative x squared minus y squared over y what? Cubed. But now we have to find the slope.
Oh dear.
So what do I just do?
Plug in the numbers.
Plug in 3 and 4. So m at negative 3 and 4 equals negative 9 squared, negative 3 squared is 9, and then negative, right? So negative 9 minus 16.
Wouldn't it be plus?
No, because no. Which one? The 16 or the 9?
The 9.
No, because this negative right here is outside the parenthesis.
Which one?
This one right here. So you square the negative 9, which would give you, you square the negative 3, which would give you positive 9, and then you still have this negative to tack onto it. And then
I'm confused because
it's negative 3 squared. Maddie, did that help?
So why wouldn't it be positive 16?
Because it's minus 4 squared. So you got to square it first and then multiply by a negative. Okay, over 4 cubed is 64. So what's 9 plus 16?
25.
25. So you get negative 25 over 64. Now you can look up whatever you need to enter. I just wanted to watch that. Okay, so when you do this, when you do a second derivative, when you get that dy dx, you go back and plug in what? Dy dx? And your assignment is all those. I just wanted to keep doing practice problems with you.